Hello everyone, good morning. Am I audible? Okay, perfect. Okay, so let's begin with the session. So what did we do in the last 2-3 sessions here? We are done with one of the most important topic for entire Java. Okay, so this is one of the most trickiest and the important topic, which we did was upcasting and downcasting. And yesterday we saw during upcasting and downcasting, we experience an exception called as class cast exception. And how do we handle it? I mean, handle in the sense, how do we avoid it with the help of instance of, okay? And we saw loads of examples here. And I received assignments here, okay? Not from everyone, but from a few people. Okay, good. Rest of you all can do whatever you want. Okay, if you're serious about your life, you'll do something in it. If not, it's up to you all. Okay, I'll train. I'm happy. I get paid. I'm happy. More than happy. Okay, so it's fine. So if you want to get placed, get a job. Okay, you want to do something in life. So make sure you practice well. Okay, great. So perfect. Okay, so today's session is all about a very important topic again. We are going to discuss something called as polymorphism. Okay, so we are going to discuss something called as what, guys? Polymorphism. Before starting with polymorphism here, okay, let me talk about something called as method binding. Okay, so there is a process called as method binding. Okay, today's topic, trust me, we are already done with it, but you wouldn't be aware of it. Okay, this was only called as method binding, this was only called as polymorphism. You wouldn't be aware of it, but we are done with the session. Okay, so I'll tell you what is method binding here. Okay, guys, see here, if the if there are m1 method, okay, this is one way. Second, m2 method, okay, and there is m3 method. So there are how many methods here into my Java program? So there are three methods over here, m1, m2, m3. Okay, so it has certain implementation as well. Okay, it has certain implementation as well. So now, okay, now if I tell m1 of, okay, what do you understand? This is nothing but the caller. Okay, calling, okay, invoker. Okay, he's trying to call the method. When I tell m1 of, which method implementation should get executed? Is it m1 method implementation, m2 method, or m3 method? It's common sense, no? If I try to call m1 method, m1 method's implementation should get executed. Correct? So now when I tell m3 method, okay, which method implementation should get executed? It's common sense that m3 method's implementation should get executed. Again, when I tell m2 method, okay, there's no method. Why? Because it's accepting an integer argument. So I'll pass it as m2 of 10. When I tell m2 of 10, it means this method implementation only should get executed. So this is called as method binding. What is method binding? Associating. Okay, associating, or we might also use the term called as mapping. Okay, associating or mapping the method caller to its respective method implementation is called as method binding. If I tell m1, m1 method implementation should get executed. m2, m2 method implementation should get executed. m3, m3 method implementation should get executed. So associating or mapping the method caller with its respective method implementation is called as method binding. Long back, in our school days here, we had something called as match the following. Correct. We had a concept called as what? Match the following. Right. So now, what do you understand over here? So there is 1, 2, 3, imagine. And the respective data is, okay, 20, 30, and 10. So now, what did you understand here? If it is 1, so the control will go over here. If it is 2, the control will go over here. If it is 3, the control will go over here. You know what is match the following now? Okay. Similarly, we are matching or mapping or associating the caller to its respective implementation. So this is called as method binding here. If I tell M1, M1 method implementation should get executed. M2, M2 method implementation should get executed. M3 method implementation should get executed. We are matching, okay, which method. When I try to call M1 should get executed. M2 should get executed. M3 should get executed. So this process is called as method binding. Got it? It's a simple part, okay. We understood what is method binding, and the reason I did is for understanding polymorphism. Okay, so let us try to talk about it. So now we will jump into polymorphism. What is polymorphism, guys? It's a normal English terminology, correct? Polymorphism means many forms. In simple English, polymorphism means poly means many forms, right? Polymorphism, it means many forms here. Got the clarity here? Okay. So in Java, sir, in normal English, polymorphism means many forms. Perfect. But how do we relate it with respect to Java is what we are supposed to understand. With respect to Java here, okay, we are talking about a method. Okay, polymorphism means with respect to a method here. Okay, sir, how do we understand that, sir? Okay, I will tell you in a beautiful manner. Okay, see here. Polymorphism means the ability the ability of a method to behave differently when different objects are acting upon it. A single method only, but it is behaving differently when different objects are acting upon it. You will understand this again at the last, since I'm done with polymorphism entirely. So what is a polymorphism? The ability of a specific method to behave differently, to exhibit different forms when different objects are acting upon it. When different objects are acting upon it. This is called as polymorphism. In simple words, okay, see, imagine you have a method called as work method. Okay, you have a method called as work method. So the ability, okay, the ability of the work method to behave differently when different objects are acting upon it. Meaning, if a developer is working on it, his work is different. Tester is working upon it, he's different. If an HR is working, his work is different. A single method called as work, the ability of the work method to behave differently when different objects are acting upon it. If a developer is working, if a software developer is working, his work is different. If a software tester is working, test engineer, his work is different. If a HR is working, his work is different. So the ability of a method to behave differently is called as polymorphism. We can relate it with respect to real time as well, guys. Okay, real time you relate it, we will get it. Okay, for example, see here. You're in the first floor. Okay, you're in the first floor over here. And if you want to go to the fifth floor here, okay, if you want to go to the fifth floor here, what are the different ways here? Sir, I can make use of a staircase, sir. I am in first floor. If I want to go to the fifth floor, that is my aim. From first floor, I have to reach the fifth floor. But there are multiple ways for reaching it. What is it? I can make use of the staircase. I can make use of a lift, or else I can make use of an elevator. So meaning my goal is to reach from first floor to fifth floor. But there are different ways for reaching it. Multiple forms, polymorphism. Okay. Now imagine you are shopping. Okay. Online shopping. Okay. Online shopping. You can make use of any application. Flipkart, Amazon, Myntra, Ajio, you name it, we have 1,000 applications for it. Okay. Any application. So you purchase a product. Okay. You're doing online shopping. You purchase a product. Now at the end of the at the end of the process here, you need to pay the amount, correct? So in order to pay the amount, you can make use of multiple ways here. You can make use of Paytm, you can make use of Phone Pay, you can make use of Google Pay, you can make use of Amazon Pay, blah blah blah, Airtel Money, blah blah blah, anything you wish to. You can make use of net banking, you can make use of cash on delivery, you can make use of credit card, you can make use of debit card. What does it mean here? Okay, credit card, debit card, meaning in simple terms here, we are trying to perform same action. That is a single action, that is pay the amount. But there are different ways for it. So this is all about polymorphism over here. Got the clarity, guys? But how do you relate it with respect to real time? Java's perspective, the ability of a method to behave differently when different objects are acting upon it. Got it? Perfect. So there are two types of polymorphism here. So whenever we talk about polymorphism, there are two types of polymorphism. What is it? First one is called as compile time polymorphism, and the second one is called as a runtime polymorphism. So there are two types of polymorphism, guys. What is it? Compile time polymorphism and runtime polymorphism here. Okay. What is compile time polymorphism? What is runtime polymorphism is what we are supposed to understand. Okay. So compile time polymorphism, in order to achieve, we have to make use of method overloading. Don't you think so? We are already done with method overloading, correct? Compile time polymorphism is nothing but method overloading. And runtime polymorphism is nothing but I have to make use of three rules. That is a relationship, okay? Method overriding, okay? Method overriding, and then upcasting. So all the topics are covered. See, I've done with overloading, easy relationship, overriding, upcasting. I'm done with everything. But we have to understand how is it called as polymorphism over here. So this is all about polymorphism. I go back to the notes here. Okay, you'll be able to get the clarity over here. What is method binding, guys? The first topic we did today is nothing but method binding. What is method binding? Associating or mapping the method collect to its respective method implementation or definition is called as method binding. If I tell M1, M1's method should implementation should get executed. M2, M2 method implementation should get executed. So we are trying to map it. Okay, we are trying to match it or map it. That process is called as method binding here. Okay, and polymorphism. We jumped into the topic called as polymorphism. What is polymorphism? Polymorphism means many forms. Okay, in simple English, it means many forms. But how do we understand polymorphism with respect to Java? See, the ability of a method to behave differently when different objects are acting upon it. A single method only, but it is showcasing different functionalities when different objects are acting upon it. Okay, so in other words, the ability of a method to exhibit different forms when different objects are working on it or acting upon it. Okay, so what are the two types of polymorphism we have? Compile time and runtime. How do we achieve compile time? It's method overloading. Runtime is a relationship, overriding, upcasting. So we need to understand what is method overloading. And I am done with method overloading long back for you all. Okay, I'm done with method overloading long back. Okay, it's not a new process which you'll be understanding it today. Okay, method overloading is done long back. But let us try to understand what is method overloading. Okay, so before that, let me create a new Java project. Okay, new Java project, and the Java project name I can give whatever I want. So I'll just give it as polymorphism. Okay, I created a Java project and that Java project name is polymorphism, and then let me create a package. src is the root folder. Under src, let me create a package. Control N. Under src, shortcut key Control N, and I will create a package, and the package name is, I'll just give it as compile time. What is the package name I'm trying to give? The package name is compile time. Okay, and I tell finish. So what happened here? We created a project, we created a package, and we are supposed to create a class. Okay, right click. Okay, now let me create a new class here. So there's no, see, right click, new. You have to search for something called as new. If there is no new option here, oh, I'm so sorry. Okay, right click on compile time, the package, click on new, and here if you can find an option called as class, it's fine, or else click on other, that is nothing but Control N. Here search for class. Okay, and the class name is, you can give anything, I just give it as Mintra. Okay, what is the class name here? The class name is Mintra. You know what is Mintra, right? It's an e-commerce application. Okay, so online shopping application. So here it's a very simple example over here. Package compile time, meaning it's a folder. Okay, there is a folder which I have created, and that folder name is compile time. And class is a blueprint of an object, and public is the access specifier, and mintra.java is a class present in compile time, uh, package. So now, what is method overloading? See here, I will have a method called as purchase. I will have a method called as purchase, open parenthesis close, open curly braces close. And I'll also have one more method with the same name, purchase, open parenthesis close, open curly braces close. And why is it giving an error? Sir, return type, sir, who will write? Okay, I should only write no. So I'll write the return type as well. Okay, so now here, what is method overloading or what is compile time polymorphism? I'll explain. Okay, see here, in a class, what is method overloading? In a class, having multiple methods with the same name, meaning the process of having n number of methods, multiple methods with the same name, but there should be a change in the arguments here. When I tell change in the arguments here, it means there should be a change in the number of arguments or data type of the arguments or the sequence. So there were three rules, no? I hope you all remember it. Okay. There should be a change in the number of arguments or data type of the arguments or the sequence of the arguments. Meaning there should be change with respect to the parameters or arguments. Simple. Okay. But here, sir, the number of arguments are same. No arguments at all. Therefore, here it will accept the string and it will take a variable called as product name. What is the product you want to purchase? So now there is a change in the number of argument. See, int string product name, it is accepting one argument, but here it is not accepting any arguments. Here I will take string product, okay, product name. Okay, it gives an error. Why? Sir, same number of arguments. If the number of arguments are same, there should be a change in the data type here. So in here I will tell it as int cost here. So will it work here? Absolutely. Why? Sir, there is a change in the number of arguments. See, one argument, but here it is two arguments here. So therefore there was a change in the number of arguments. Okay. Now similarly I'll have the same method. Okay, purchase method only. But now what I'll do, okay, so here I'll just write it as one argument over here. So it will give an error. Why? First, second method are giving an error. Why? Because sir, the number of arguments are same. What if I change the variable name? It doesn't matter. All matters is the data type. You could look at the bottom of the screen. It's telling duplicate method purchase string in type mintra. Okay. So here I'll just write it as int product ID. So what did you understand over here? Sir, the number of arguments might be same. One argument, but there was a change in the data type here. Here it is taking string, but here it is taking int. But first method, second, and the third method. See, there is a change in the number of arguments. Here one argument, but here it is taking two arguments. Got it? So this is what we are supposed to understand. And now, okay, this is all about it. I'll maximize the screen. Again, third and fourth method are giving an error. Why? Number of argument is also same. Data type is also same. Sequence is also same. Everything is same. Okay, now, so this is the reason it's giving an error. So therefore, what I'll do here is, I will take this and I will write it over here. So there is a change in the sequence. See, here it is string and int, but here it is int and string here. So there was a change with respect to the sequence here. Okay. So this is the reason we call it as compile time polymorphism. That is method overloading. Got it? So let me just write it down over here. Okay. So just let me write it down the product name over here. I'll just try to print everything. Okay. Product name. I'm just trying to print the content over here. Okay. So the people who all know it might be repetition for you all, but it doesn't matter. Okay, but it's all revision for you all. Okay, so here I'll just write it as product name plus give a space plus cost. Okay, and here I'll print the cost here plus, and I give a space and I'll just give the product name. Okay. So this is absolutely a valid Java program. Okay, this is an example for compile time, method overloading. Okay, but why do we call it as compile time polymorphism? I'll tell you. Okay, I will have a class called as customer. Okay, I am the one who is trying to purchase some data here. So customer class is on my RHS over here. Okay, so now here guys, my execution will always start from main method. Okay, execution always starts from the main method over here. Since it's a non-static method, I have to create an object of Mintra. Okay, it's mandatory that I will create an object of Mintra here because all these are non-static methods here. Okay, so now I'll tell m dot. Okay, I'll tell purchase of. Okay, I am passing 101. Now tell me, where will my control take me to? It's ultimately single method, purchase only everywhere. It's purchase method only. But since I'm passing an integer argument here, now quickly tell me, where will my control take me to? Is it the first method, second method, third method, or the fourth method? Sir, common sense, sir. Okay. Press Control on your keyboard. Okay, press Control on your keyboard. Hover on the method. Okay, hover on the method and click on it. Once you click on it, the control is going to the second method over here. Since it is accepting an integer argument, okay, I'm passing 101. The control takes me to the second method. Who decided? So as soon as I pass 101, my control has to go to the second method only. Who decided? The compiler decided during compile time only. The decision of, see, out of so many overloaded methods, the second method only should get executed. Who took the decision? The compiler took the decision during compile time. That's the reason here we call it as compile time polymorphism. Understood? Again, I will tell m dot purchase of. Okay, m dot purchase of, and I am passing 1000, and the product I want to purchase is, imagine it is mobile here. So now tell me, where will my control take me to? Press control on your keyboard, hover on the method, click on the method. My control is taking me to the fourth method. Who took the decision that the fourth method only should get executed? The compiler took the decision during compile time only. Oh, I'm passing int and string. Execute the fourth method. So that's the reason. See, it's compiling now. Okay, it's compile time. I'm not yet executed the program. It's still compiling. See, as soon as I remove the semicolon, it will give me compile time error. It will tell, hey, dabba fellow, add one semicolon over here. So in Eclipse, the compilation is happening during coding only. Okay, internal it will happen. Again, if I tell m dot purchase of, and I want to purchase a laptop. Okay, so where will the control take me to? My control will take me to the first method. Why? Sir, I am passing a string argument, sir. Therefore, the control will take me to the first method. So this is the reason we call it as I want to purchase one shoe. Okay, and the cost of the shoe is, imagine it's 5000. So now where will the control take me to? See, the third method. Out of so many overloaded methods, the decision that this specific method only should get executed is decided by compiler during compile time, meaning the method binding is happening during compile time, meaning, so if as soon as I pass 101, method, second method implementation should get executed. As soon as I pass laptop, the first method implementation should get executed. The method binding is happening during compile time only. That's the reason we call it as compile time polymorphism. Got it? So this is all about it. This is not a new topic I'm doing now. Compile method overloading is already done, but you have to understand this is only compile time polymorphism. Okay, so this is what has been written over here. See, compile time polymorphism is achieved with the help of method overloading, and we know what is method overloading in a beautiful way. And compile time polymorphism. So ignore the second point. We'll talk about it. Method binding is happening as compile time. Method binding is happening at compile time. Okay. So what is method binding? I told you, associating. So method binding is happening at compile time, meaning when we call a method, okay, we call a method as early binding or static, blah, 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 blah. Okay, ignore it. Okay, see here, out of so many overloaded methods, okay, which implementation should get executed is decided by compiler during compile time only. Okay, so the method binding is happening at a compile time. That's the reason we call method overloading as early binding or static binding here. Early binding meaning it is happening early only, even before execution it's happening. So that's the reason here it is early. And static meaning it's not changing, it's always the same, right? So that's the reason it is static binding, or we also call it as compile time polymorphism. One terminology, one concept, method overloading concept that can be referred in n number of ways. That is early binding, static binding, compile time polymorphism. Everything means the same. The only thing you have to tell, why do you call method overloading as compile time polymorphism? That's your question. You will explain method overloading in a beautiful way. The interviewer will ask, hey, okay, you explained what is method overloading. I'm happy. But why do we call it as compile time polymorphism? You will tell, sir, the method binding is happening during compile time. That's the reason we call it as compile time polymorphism. What is method binding? Meaning, when I pass 101, second method implementation should get executed. If I pass laptop, first method implementation only should get executed. So we are trying to match, we are trying to map. That is called as binding. Okay. Out of so many overloaded methods, first method implementation only should get executed. Second method implementation only should get executed. Who takes that decision? The decision is taken by the compiler during compile time. That's the reason we call it as method overloading as compile time polymorphism. Got it? I hope you all got the clarity here, right? So we understood what is method binding, we understood what is polymorphism, and we understood what is compile time polymorphism. So what are we left out with? We are left out with runtime polymorphism. Clear? Before going ahead with the topic, anyone having any doubts with respect to whatever we discussed now? See, if you just execute it, I will get the beautiful output here. So I'll get the output. See, did we get the output here? Yes, absolutely. I got the output. So let me write down the output over here only. So it becomes easy. Okay. So that, I need not think about anything else. Okay. So this is the output here. So now quickly tell me here, do you all have any questions here? Okay. Any questions anyone quickly answer? Very good. Cool. Okay. Great, guys. Good. Okay. So this is a very, very simple topic, but we are just supposed to understand the flow. Okay. So the next topic is really important. Okay. I want everyone to concentrate now. Okay. So now, first of all, we have to understand what is runtime polymorphism. Runtime polymorphism is achieved with the help of what? Easy relationship, method overriding, and upcasting. So can we quickly do it here? Easy relationship, overriding, and upcasting practically only? Huh, yes, sir. We'll do it now. Let me create a package. Control N. I create a package, and that package name is runtime. Okay, and the package name is runtime polymorphism. Under that package, we will create a class, and the class name is vehicle. Okay, so I'll take this example only, vehicle class only. Okay, under vehicle class, I will have one method. Okay, control M will maximize the screen. Okay, I will have one method. Void is the method name. Void is the return type. Start is the method name. Open parenthesis close, and the implementation I will just give it as, okay, vehicle started. Okay, vehicle started. Got it? I have created a class called as vehicle, and it has a non-static method called as start method. Okay. Now here I'll create one more class called as car. Okay, I'll create a class called as car here. So now here, the first rule here is I need to achieve easy relationship. For achieving runtime polymorphism, easy relationship is mandatory. So as I told you when I did inheritance, inheritance is one such topic which you'll be coming across it widely. Okay, so you will tell extends what? Public class car extends which class? Vehicle class. Rule number one done. Easy relationship is successfully achieved. Rule number two, method overriding. While overriding the method, what is overriding? Sir, you have to inherit the method, sir, and change the implementation of that method. So while overriding, return type is same, Method name is same, arguments is also same, but there is a change in the implementation. So here I'll just write it as car started. So we are done with the process here. Is it an overridden method? Yes. So I can write optionally annotation override. So even if you don't use this annotation, it will work. Okay, I like it, I'm using it. Okay, so how many rules done? Two rules. I have achieved easy relationship and I have achieved method overriding. Overriding meaning inheriting the method and changing the implementation of that inherited method. Got the clarity here? Understood? Great. So now I'll have one more class. Okay, I'll have a class called as bike class. Okay, so here inside the bike class, even bike class will do the same thing. Okay, even bike class will do the same thing over here. That is nothing but is a relationship extends vehicle. Okay, and then overriding void start open parenthesis close and open curly braces close, and I'll just write it as bike started here. So is it an overridden method? Absolutely. So I'll just write it as annotation override. So car class inherits vehicle and has overridden the start method. Bike class inherits vehicle and has overridden the start method. Got the clarity here? Understood? Perfect. Now can you tell me what type of relationship is this? Easy relationship. Don't tell sir this is easy relationship, sir. I know this is easy relationship. Under easy relationship, what is the type of inheritance is this? Is it single level, multi-level, hierarchical, or what is left out? Whatever it is. Okay, just quickly tell me what type of inheritance is this? Think and tell me. You give wrong answers, I'm going to kill you seriously. We have done it yesterday also. I don't want a single wrong answer here. Okay, very good. Okay, it's hierarchical inheritance. Okay, so majority of you have told it correctly. Okay, good, good. Okay, very good. Okay, so it's hierarchical inheritance. Okay, now here, what is upcasting? Sir, upcasting easy, sir. Don't you know it? Ah, I know it. Okay, so we'll do upcasting. See, creating an object of subclass and storing its address into a reference which is of type superclass here. This is called as upcasting. Correct, no? So we are creating an object of subclass and storing its address into a reference which is of type superclass. Okay. Now when I tell v1.start method, now tell me what will be the output here? What will be the output here? Yeah, now you should tell me, no, what will be the output here? Think and tell me. I'll tell you. I'll give you one hint. The output is vehicle started or car started or bike started. You can just tell me VS for vehicle started, CS for car started, BS for bike started. Out of these three, there's only one answer. Tell me what should be the output. Okay, so majority of you have told it's either car or vehicle, car or vehicle, car or vehicle. Okay, VSCS, I get multiple answers. So, majority of you told here, sir, car is involved, vehicle is involved. So, the output should be between vehicle started or car started. You're good. Bike is excluded. Why? Because we have not at all used bike anyway. So, bike is excluded over here. So, the output should be between car started or vehicle started, right? For your surprise over here, okay? For your surprise over here, let me execute it first. Okay, let me execute it first. You see the output here. What is the output we got here? So we got the output as car started, correct? We got the output as what? Car started. Why did we get it as car started? Okay, I will tell you in a beautiful manner. Okay, we got the output as what? Car started, right? So start method is an overridden method. Do you all agree? Yes, sir. Start method is an overridden method. I agree. So when you call an overridden method on the superclass reference, okay, it doesn't matter. Always overridden implementation only will get executed. So you have to fix one thing in your mind. That is, whenever you call an overridden method, okay, it doesn't matter if it's the superclass reference, meaning the upcasted reference, or the subclass reference. Always the overridden implementation only will get executed. Got the clarity? If a method has been overridden, it doesn't matter if it's the upcasted reference or the subclass reference, always the overridden implementation only will get executed. But now there are two overridden methods. In car class also it's overridden, in bike class also it's overridden. But which overridden implementation will get executed? It is dependent on the subclass acting upon it. So the car object is happening, no car object, subclass object. So the car started will get executed. So clearly listen, okay? When you call an overridden method on the upcasted reference, on the superclass reference, the method implementation which gets executed is decided by the subclass acting upon it. What is the subclass acting upon it? Car. Therefore, the output will be car started. So when I execute, I will get the output as car started. See, I will get the output as car started. But now, press Control on your keyboard, hover on the method, click on it. See, the control is taking me to vehicle started, but the output I'm getting here is car started. That's the reason we call it as late binding. The method binding is happening at the runtime. Here, which method implementation should get executed is decided by the JVM, okay, at runtime. Okay, during compile time, he will assume that vehicle started should get executed. See, press Control on your keyboard, hover on the method, click on it. He will assume that vehicle started should get executed, which is in vehicle class. But now, once a object gets once an object gets created and overriding is happening, the JVM will decide which method has to get executed at runtime. Okay, compile time polymorphism, compiler will decide at compile time. Runtime polymorphism, JVM will decide at runtime. Okay, got the clarity here? So this is called as late binding or dynamic binding. It is happening lately. Okay, meaning once I execute it, that is when the binding is happening. So that's the reason we call it as runtime polymorphism, as late binding or dynamic binding. Okay. Similarly, see, create an object of subclass and store its address into a reference which is of type superclass here. This is upcasting. Now when I tell v2.start method, which start method will get executed? Is it vehicle started, car started, or bike started? VS, CS, BS. What should be the output? VS, CS, BS. What should be the output? Very good. So the output should be BS here. Why? Sir, when you call an overridden method on the superclass reference, the method implementation which gets executed is dependent on the subclass, sir. So the subclass is bike, sir. So the start method in bike will get executed. Who took the decision? The JVM took the decision at runtime. That's the reason we call it as runtime polymorphism. Okay, late binding or dynamic binding. Got it? So this is all about, okay, polymorphism here. So once I go back to my notes here, read out what is runtime polymorphism, you'll only get the clarity. See, runtime polymorphism can be achieved with the help of easy relationship, method overriding, and then upcasting here. So these are the three rules I need to satisfy. Okay, got the clarity? So now here, okay, see here, read out the note first. Read out the note first. When you call an overridden method, okay, when you call an overridden method on the superclass reference, always the overridden method only gets executed. Okay, see, it doesn't matter, guys. Okay, if it's the upcasted reference or the subclass reference, if you have overridden the method, always the overridden implementation only will get executed. Got the clarity here? So that is what I told. When you call an overridden method on the superclass reference, okay, the method which gets executed is dependent on the subclass acting upon it. So out of so many overridden method, which implementation should get executed is decided by the JVM at runtime. That's the reason we call it as runtime polymorphism. Again, we have different names they have given. Late binding, dynamic method dispatch. Okay, everything means the same. Okay, but different terminologies to refer to the same concept. Got the clarity? Understood over here? See, this is only called as polymorphism in simple terms. Okay, so what did we do here? See, we had a method called as start method. We had a method called as start method. Okay, the ability of the start method to behave differently when different objects are acting upon it. When the bike object is acting upon it, bike started. If the car object is acting upon it, car started. A single method only start. The ability of the start method to exhibit different forms when different objects are acting upon it. So just remember this point. That's more than sufficient. Okay. So this is all about, okay, compile time polymorphism, runtime polymorphism, and the binding what we are supposed to understand. Clear everyone here? Okay. I shall be giving one more example for it here. But before that, everyone understood what we did now? Anyone having any questions? I'll give one more example. Don't you worry. Okay. But as of now, any questions, guys? You want me to interrupt? You all want me to interrupt here and talk about something else here? Let me know. Any questions as of now here? Very good. Perfect, guys. Perfect, perfect, perfect. Okay. So now we will talk about one more example because I want you all to understand in a beautiful manner. Okay. So now you need to apply a bit of common sense now. Okay. Because I'm just going to make it tricky for you all. Okay. Because I want you to understand that flow as well. Okay. So I'm going to make you a little bit of tricky part. Okay. But I hope you'll all understand and you'll all respond properly. Okay. I have a class called as employee. Okay, I have a class called as employee, and this guy will have a method. Void is the return type, work is the method name, and the implementation, I'll just write it as employee is working. That's it. Okay, I'm not going to do anything else here. Okay, I'll just write it as employee is working. Okay, got it now? So let me create one more Java program, and that is nothing but developer. Okay, so here I'll just write it as developer. What is the employee name, employee designation? He's a developer. Okay, so now what will the developer do here? So first rule, he has to achieve easy relationship, sir. Okay, easy relationship means extends employee. Okay, I hope you all got the clarity. Correct? Developer extends employee and he has to override the method. For overriding, what am I supposed to do? Same return type, same method name, same number of arguments, but there should be a change in the implementation. So here, what is the job of developer here? Okay, design, okay, design and develop, okay, develop applications here. Design and develop applications. That's it. Okay, the job of a developer is to design and develop an application here. So since this is an overridden method, I can optionally write it as annotation override. Got it? Is a relationship overriding. Oh, beautiful. Okay. So now I'll have one more class. That is tester class. Control N. Okay, control and tester. Oh, I'm so sorry, tester. I'll just rename it, hover on it, rename to tester.java. Very good, perfect. So easy relationship. Extends employee, right? Tester extends employee, okay, and overriding void work method. What will be the implementation of the work method? Tester design test case, design test case, and test an application. Design test case and test an application. Okay, I'm just writing it. Okay, he will design the test case first. Okay, after designing the test case, he will test an application. Okay, for the clarity, so this is an overridden method. So I'll write annotation override. Okay, we're done with this entire process. So we have two classes over here. Okay, so this is all about the entire process over here. So now we will have our main class over here. Okay, so wherein the execution will begin from. So I'll have my runner class. Runner class is wherein I'm going to execute it. Okay, so now in the runner class here, okay, so there are three ways which I'll be doing it over here. Okay, there are three ways I'll be doing it over here. So I'll have my main method wherein the execution will always begin from. So here what I had to do here. So first of all, I had to upcast it, creating an object of subclass. Okay, and storing its address into a reference here, which is of type superclass here. So this is called as upcasting. See, superclass reference, subclass object. Correct? No? E1 dot work method. Oh, so I'm so sorry, not wait method. It's work method. E1 dot work method. So now tell me, which work method should get executed? Sir, it's pure common sense, sir. Okay? It's very simple part. Sir, when you call an overridden method on the superclass reference, the method implementation which gets executed is based on the subclass acting upon it. So the work method, okay, is overridden in developer class and the developer object is acting upon it. So obviously the work method in developer class will get executed, wherein the output will be design and develop applications here. Did I get the output here? Yes. Similarly, I will create upcasted. See, new tester object I created, and I will store it into a reference E2, which is of type, okay, employee. Superclass reference, subclass object. When I tell E2 dot work method, again, when you call when you call an overridden method on the superclass reference, the method which gets executed is dependent on the subclass. So which is the subclass acting upon it? Tester. So the work method in tester class will get executed. But who took the decision here that the work method on tester class only should get executed? The JVM during runtime he will decide, not during compile time. See, control and hover on it. Compile time he will assume the output should be employees working. See, press control on your keyboard, hover on the method, click on it. He will think that employee working should get executed. But at the runtime, when say method gets overridden and stuff, right? Okay. So when now he will decide that, okay, JVM will decide at runtime which method should get executed. That's the reason we call method, runtime polymorphism as, okay, late binding or dynamic binding. It's happening late. Okay, not immediately, it's happening late here. So this is all about the entire process here. Imagine guys, once a method has been overridden, it doesn't matter if it's the superclass reference or the subclass reference, always overridden method will get executed. But which overridden method is decided by the JVM? How? Based on which subclass is acting upon it. Got the clarity? So which overridden method should get executed? So it's dependent on the subclass. Who decides it? JVM. So this is what we are supposed to understand here. Got it? Perfect guys. Okay, very good here. Okay, so we are done with one set of understanding, but I have to do it in different ways. Okay, so have patience level over here. I'll tell you here. What am I trying to do here? No, I will tell you here. See, this over here, I am making use of multiple references here. This can be avoided here. Okay, how can you avoid it over here? So you can avoid it by having employee EMP. I will declare it. EMP is of type employee, so he can store the employee object and the subclass objects here. So EMP equals to new, okay, I can write it as developer over here, and I can tell EMP dot work method, not the wait method, EMP dot work method. Similarly, I can reinitialize EMP equals to new tester of, okay, and I can tell EMP dot work method over here, okay. So this is how we can do it. We can reduce it. See, I'm making use of different references, no, two references here. So I'll declare it once, but create an object multiple times, okay, based on different content here. So once when I execute it here, I should be able to get the output. See, design and develop applications, design and develop applications. Got it? So this is all about how we are supposed to understand the actual content here. Got it here? But it's all overriding. Got the clarity here? Understood? Perfect. Okay. So any confusions guys with respect to whatever we did in today's session here? We started the session with, wait guys, I'm not yet done. Okay, I have one more thing to explain. Okay, don't run away. As soon as I tell what did we discuss in today's session, you'll be like, oh sir, we're done with the session, sir. No, I'm not done. Wait for it. See, we started the session with something called as method binding. Method binding means when I try to call a method, which implementation should get executed. That is called as method binding. Associating the method caller to its respective method implementation. That is binding. Okay. Polymorphism we understood. The ability of a single method to exhibit different forms. Okay, now. But what is different types of polymorphism we have. Okay, the different types of polymorphism are, okay, it's very simple. See, what is polymorphism, guys? Simple. The ability of a method to behave differently when different objects are acting upon it. So polymorphism are of two types. What is it? Compile time polymorphism and runtime polymorphism. Okay, compile time polymorphism can be achieved with the help of method overloading. Runtime polymorphism is a relationship, method overriding, and upcasting. Got the clarity here? Compile time polymorphism, compiler will decide which method to get executed. A runtime polymorphism, JVM will decide which method should get executed. During compile time, out of so many overloaded methods, which method implementation should get executed is decided by whom? By the compiler. In runtime, out of so many overridden methods, which overridden implementation should get executed is decided by JVM at a runtime. Got it? Compile time polymorphism is called as static binding or early binding. Why? Because it is happening during compile time only. Static does not change. Early, it is happening during compile time only. But runtime polymorphism is called as dynamic binding or late binding. It is changing. If it is car is acting, the implementation is different. The bike is acting, the implementation is different. So it is called as dynamic binding. It keeps on changing. Late binding because it is happening at the runtime. Got it? So this is how beautifully you have to explain what is polymorphism and what is the difference, different types of polymorphism here. Got it? Understood? I hope I have done this entire data here. Okay, so there is one question. What is the output when superclass reference calls overridden method and reference is not upcasted? I didn't get your question. What if the output when superclass reference calls overridden method and the reference is not upcasted? Okay, I hope you're just creating a normal object. Okay, see here, I'll tell you. I hope I got your question. Okay, I'm not sure. Sir, what if I just create an object of employee, sir? Employee E equals to new employee of. Okay, so now, and when I tell e dot work method, what will be the output, sir? See, I am not upcasted. Okay, so doesn't matter. So now since I have not upcasted, I'm just creating a normal object of employee. So here I create a normal object of employee wherein it is having the work method. So there is no easy relationship, nothing as of now. Why? Because only we are considering the employee class. That's it. See, is there any easy relationship here? No, nothing. So you have created an object of employee and you're calling the work method. Aste. So your output will be employees working only. Okay. Your output will be employees working. Where the hell is this class here? Just a moment. I have to remove this. Yeah. Go back here. Your output will always be employees working. See, you got the output employees working. Why? Because there's no easy relationship overriding happening. But that is what I told. Once a method is overridden, if we call an overridden method on the upcasted reference, when I tell superclass reference, I mean to say it is the upcasted reference. This is an upcasted reference, no? That way. If you create a simple normal object here, normal implementation only will get executed. Why? Because overriding will happen only when I create an object of subclass. Okay. If I'm not created an object of subclass, how will the overriding happening? That way. Okay. So easy relationship is there. See, now if there is developer, okay, developer, and what do you want to tell here? Which object should I create over here? Whose object should I create here? See, you told easy relationship. Okay, so what are you trying to tell here? You just tell me what is the syntax here, I'll go ahead with that. You tell me what am I supposed to do here? Whose object should I create here? Superclass object, employee. After that, reference E I took. Then which object should I store here? Is it employee, developer, or tester? Employee only. No, it becomes like a normal object, Mahesh. Sorry. See, this is new employee. I am creating a simple object of employee. So you're just keeping in mind only the employee class. Once you create an object of employee class, there is work method. See, employee is not inheriting another class. Okay, so there is no point of overriding an inheritance over here. Okay, no upcasting also. But internally it's object class, that is secondary. Okay, but here now developer is inheriting employee and the method has been overridden. Once you create developer object, that is when the problem will occur, because the method is overridden, right? So always the overridden implementation only will get executed. Got the clarity here? So is a relationship meaning where will I have is a relationship? Okay. Tell me. Go ahead, Mahesh. Got it right? Perfect. Okay, great. Perfect. Because developer is inheriting, not employee. Employee is not inheriting. Developer is inheriting employee. Okay. So always we have to keep in mind with the subclasses here. Okay. So this is what we had to discuss in today's session, guys. Okay. So we are done with method binding, polymorphism over here, or compile time polymorphism and runtime polymorphism. Okay. We are done with almost everything here. But I have a small question here. I hope you'll all answer. Okay. I don't want you all to screw it up. Okay. So now imagine, guys, I will have a method called as invoke. Okay. So here in that invoke method, okay, I will call the invoke method and I will pass, okay, new tester object. Okay, new tester object. So what should be the reference over here? So the reference should be obj and the type should be tester. Why? Obj is of type tester. It can allow only tester objects. Got it? Similarly, I will have a method called as invoke and I am passing new developer here. Okay. So now here, if I'm passing developer over here, obj should be of type developer. So if it is tester obj, only tester objects are allowed. So this is specialization. If I add developer obj, only developer objects are allowed. Again, this is specialization. Okay. Tester obj means only tester object. Developer obj means only developer object. But I have to create a method in such a way I should be able to store the tester object also. I should be able to store the developer object also. So what am I supposed to write the reference type as? Now if you give me wrong answers, I'm just gonna tell lot of things. What should be the output? Sir, common sense. What is it? Tester and developer have a common class. What is it? Employee. Correct. They have a common super class. So this is nothing but employee. Very good. Okay. Even yesterday we understood this generalization. Sir, creating an object of subclass, storing its address into a reference of type superclass. Creating an object of subclass and storing its address into reference of type superclass. This is generalization. Got the clarity here? Got it? So I can easily tell obj.work method. That way also we can do it here. Got it? So I'll do this process. See here. I'll create one more class called as main class. Main class. Okay, great. Main class I have. And over here, I'll have a method called as invoke work method. Invoke work method. Okay. So I'll have my main method. Oh, I'm so sorry. Wherein I will create an object of main class here. Why? Because I have to call the data. Okay. So here I'll tell invoke work. See here. So what happened here? Sir, I have a class called as main class and it has a non-static method called as invoke work method and the return type is void. So to the invoke work method, if I pass an object of tester, okay, if I pass an object of tester, here the reference type will be tester obj. So is it working fine? See, it works fine. Absolutely, it works fine without any problems here. Okay, it will definitely work fine here. Got the clarity here? Perfect. So tester obj and I'm passing the tester object. I will store the tester object into obj which is of type tester. Similarly to the same method, I am passing an object of developer. Okay, but it will start giving me an error. See, if I just hover on it, that method invoke work tester in the type main class is not applicable for the arguments developer here. Okay, So it is telling, if you write it as tester obj, only tester objects are allowed. If I write it as developer obj, only developer objects are allowed, not tester object. But I want to create a generic method wherein I want to pass the tester object also, developer object also. So I'll blindly write the superclass called as employee. So what happens? Creating an object of subclass and storing the address into superclass reference. Creating an object of subclass and storing the address into superclass reference. So I'll tell obj.work method. So now it depends. Okay, which work method I'm trying to call. Even that way we can do it. See, did I get the same old output only? Did I get the same old output? But I have done it in a different way. That's it. Okay, see, just relate these two classes here. What am I doing here? See, it's very simple here. See, creating an object of subclass and storing it into superclass reference. See, creating an object of subclass, storing into a reference which is of type superclass. See, again, same thing, no? Creating an object of subclass, creating an object of subclass that is getting stored into superclass reference. So here you can write it as EMP. So if you write it as EMP, here also you can write it as EMP. So EMP.work method. So now if the tester object I have passed, okay, so the work method in the tester will get executed. If the developer object I have passed, the work method in developer will get executed. This is what we are supposed to understand here. Got the clarity here? So these are the different ways of doing it here. Okay, you can understand however you want it. Okay, this can actually be done like this also. Okay, wait for it. See, I'll just create an object of tester. Tester t equals to new tester of. This is a normal object creation. So I will tell m dot invoke work method of t. Okay, and I have passed t. What is t? T is of type tester, and this is storing the tester object. So you are passing the tester object. So tester object gets stored into employee. So what will be the output? Tester is testing an application. Okay. If you create an object of developer, developer d equals new developer of, and m dot invoke work method of, you pass it as d here. Okay, if you make it a static method, no, if you make it a static method, you don't require objects and all. Okay, you don't require objects here. Okay, oh, what happened here? Just a moment. Oh, I just created a replica for it. Okay, public class main class. Okay, oh, I'm so sorry guys, I just forgot to write that. Okay, so public class main class over here. Okay, if I make it as a static method, you can directly call that invoke work method. You need not create an object at all over here, because static methods can be called directly within the same class here. You need not, do this process again. So it becomes a very easy. See, static method, no? So you are directly passing invoke work method, and you're passing the object of tester, developer. Again, tester object you created, and you're passing the tester object. Developer object you created, you are passing the developer object. So it becomes easy in order to understand. So these are the different ways of understanding the content, but absolutely the same program, but I'm trying to do it in different ways here. So these are the different things which we are supposed to understand in today's session here. Okay, I hope you all got the clarity about this entire process here. Clear guys? So this is all about polymorphism here. Okay, so if at all you have any questions, you can let me know, or watch the video once again, so you'll be able to understand it in a beautiful way. Got the clarity here? Okay, so perfect guys. Okay, so one question here. Okay, so compile time polymorphism, a few questions. Okay, so in an interview here, they'll ask one question. Okay, what is polymorphism? What will you tell? So in simple way, you will tell, sir, the ability of a method to behave differently when different objects are acting upon it. Perfect. What are the two types of polymorphism? Compile time polymorphism, runtime polymorphism. What are the other names for compile time polymorphism? Compile time polymorphism can be achieved with the help of method overloading. Okay, and it can be called as static binding or early binding. Okay, runtime polymorphism can be achieved with the help of easy relationship, overriding and upcasting, and it can also be called as dynamic binding or late binding. Okay, why do we call method overloading as compile time polymorphism? The reason is because out of so many overloaded methods, which method implementation should get executed is decided by the compiler during compile time only. That's the reason we call it as compile time polymorphism. Runtime, out of so many overridden methods, which overridden methods implementation should get executed is decided by the JVM at runtime based on which subclass object. That's the reason we call it as runtime polymorphism. Got it? So go through this entirely, and if at all you have any doubts, you can let me know. Okay. So anyone having any questions with respect to today's session, guys? Any questions with respect to today's session? You want me to repeat something? Any questions? You want me to repeat any topic? Very good. Okay. So make sure, guys. So we are done with probably inheritance, encapsulation, and polymorphism for the day. Okay. So we are left out with abstract, interface, abstraction, singleton, design pattern. So four more concepts. We would be done with OOPS. Okay. Object orientation. I mean, object oriented programming will be done. All those principles I would have covered. Okay. Then we would be jumping into the advanced topic, and I'm telling you now itself, okay, once I start with the advanced topic, okay, your prerequisite is OOPS concept. Okay, if you do not understand OOPS concept, your libraries, okay, the advanced topic will go over your head, directly over your head. Okay, so make sure, give time and start practicing at least now. Okay, 63 batch have given mock here. I'm not sure about 61 and 62. I'll cross check with Vignesh. Okay, so make sure, start preparing for mock. Okay, I might schedule it anytime. Okay, so if at all you have any questions, you can drop me a message anytime. Okay, so great, guys. Okay, so start practicing. Okay, don't leave it towards the end stage here, wherein you'll have a lot of things to cover and you'll forget a few topics as well. Okay, I don't want you all to face that thing, so start practicing now. Okay, so great, guys. Okay, so we shall wind up a session for today and catch up tomorrow with abstract topic. Okay, so thank you all, take care, bye bye.